Hello everyone, so today we're going to be looking at arithmetic sequence or arithmetic progression. So these two words are interchangeably used whenever we're going to be studying, okay? So don't be confused with that. So let's dive in. So let's see. Arithmetic progression is a consecutive, because this is the definition. Let me just say these are consecutive. This is the key term, consecutive terms with a constant difference. Here, constant difference denoted by E. Okay, so let's give you an example. Okay, imagine a sequence with this 4, 7, 10, 13, then there's a dot in here. Okay, so what do you think is the rule? Okay, if you're going to look at this, what's the rule? Okay, when I say rule, what makes it a sequence? That's what it means. So if you're going to look at it from term number 2, this is basically A1, this is A2, A3, A4, and so on and so forth. So if you're going to look at it, it says that this has to have a difference. Okay, so let's look at the difference of set between these two terms, A2 and A1. So what's going to be the difference? That's going to be A2 minus A1. So in this case, it has 3. And what about this one? Is it equal? A3 minus A2. Are they equal? Yes, they are equal. Therefore, this is an arithmetic sequence because everything is patterned by 3. So this is going to be an arithmetic sequence. Therefore, so we know that it's already an arithmetic sequence. What's going to be the rule or the formula? Okay, so we're going to see it this way. A sub n is equal to the first term plus multiplied by the number of terms minus 1 multiplied by the difference. So we know the first term in here. So our first term, A1, is going to be 4, and our difference is 3. Okay, so that's easy, quite easy. So let's now get our final one. Okay, A1 is going to be 4 plus n minus 1 multiplied by 3. That's going to become 4 plus 3n minus 1. Therefore, our final here is going to be 3n minus 3. Okay, so that's going to be 3n minus 3. 4 minus 1 is 3. So this is now going to be our explicit formula for this specific sequence. Okay, so let's see. Since we already have this explicit formula, can we find the 15th term and even the 100th term of this sequence? Yes, we can find it. How do we do that? Just put in the 15th term. So A to 15 is equal to 3 times 15 minus 3. That's going to become 45 minus 3. So our A15 is going to be 42. Okay, that's the 15th term. What about the 100th term? A to 100 is equal to 3 times 100. That's going to be 300 minus 3. It's 300 minus 3. Yeah, there you go. It's going to give you 297. Okay, so those are the answers. Okay, so in this example, we are now going to calculate a term in a given AP, or when I say AP, it's arithmetic progression. So let's see. Here you are given a sequence -3, 2, 7, and 12, and dot, dot, dot. Now, here's the requirement. Determine A20 and which term, these are now asking you which term has the value of 212 in this specific sequence. So as a solution, we're going to solve that. solution in letter A. In letter A, it's going to be easy because you're just going to look at the difference of this. What's going to be the difference? It's basically 2 minus negative 3 is going to be 5 here. 7 minus 2 is going to be 5 again. 12 minus 7 is going to be 5. Therefore, it's constant and the D is 5. So having said that, we're going to now determine the A20. So A's of 20 is equal to the first term, negative 3, plus 20 minus 1 multiplied by the difference, which is 5. Okay, that's going to be easy. Negative 3 plus 19 times 5. Okay, so totaling all of it, that's going to be 3 times 19 times 5 is 95. Negative 3 plus 95. So our A20 now is going to become 92. Okay, so that's the answer. So easy as that. Now, in letter B, let me use another color. Here in letter B, which term has the value of 212? Okay, so let's see. Let's go back to our general term formula, which is A's of n is equal to A1 plus n minus 1 multiplied by D. Okay, so given this term, we know our D. So what are the given in here? D is equal to 5. Our A1 is going to be negative 3. But we are asked which term. What is the role of 212 in here? This 212 now is going to be your A's of n, or the last term, which is 212. So let's just plug in everything in here. Okay, so let's say, so 212 is equal to negative 3 plus let's say 5n. What is our n? Do we know the n? No. N minus 1 multiplied by 5. Okay, so let's see. So in that case now, what we're going to be doing is continue with this. 212 is equal to negative 3 plus 5n minus 5. Remember, we're looking for the term which is n. This is what we are looking for. We don't know what term is that. So 212, going back to that, that's going to be negative 212 again. Negative 3 minus 5 is going to be negative 8. Can I just negative 8 plus 5n. Okay, so this is going to be plus 8 plus 8, cancel out. What's now left is going to be 5n is equal to 220. So 212 plus 8 is divided by 5 again, and 5. N is now going 220 divided by 5 is going to give you 44. So the answer in here now is that the term number 44 has the value of 212. Okay, easy, yeah? Okay, in this example, we're going to look at how to calculate a term given two terms. So in here, you're not given a sequence, you're not given an explicit formula, but you're only given two terms. So this time, if A3 is equal to 4 and A8 is equal to 34, what's A1? Oh, okay. How are we going to supposed to solve that? So what we are going to find in here, number one is we have to find the difference. Do we know the difference? Find the difference, D, and after finding it, then you can now start to find A1. Okay, let's go to the solution. The solution is very simple. Okay, let's imagine here A3 is equal to 4, and then A's of 8 is equal to 34. So I would like you to imagine that in your linear equation y is equal to mx plus b, m here is the slope, and you can find the slope by saying y2 minus y1 over x2 minus x1. So it's going to be the same in here. So what I will be doing is that I will make 4 and 34 to be my, this is going to be my y2, and this is going to be my y1, and 8 is going to be my y1, and this is going to be my hold on, okay, this is going to be my, not y1, it's going to be x2, and this is going to be my x1. Okay, so now I'm going to find the difference using the same idea. So the difference now is going to become y2 minus y1 all over x1 minus x2. So let's put that in. That's going to become 34 minus 4 over 8 and 3, 8 minus 3 is going to give you 30 over 5, which is 6. Okay, so your difference is 6. Okay, now can we find out the A1? Yeah, we can find out the A1. Just get another, you can just get any. Let me just delete this part. Okay, find A1. Now let's use another color. I want blue to find A1. So in finding A1, you can now use any of these two terms, okay? Any of the things. So I'm going to choose A3. Okay, so say A3 is equal now to my A1 plus n minus 1 multiplied by the d, which is difference. Now, I know the value of A3. What's the value of my A3? The value of my A3 is 4. My A1, do I know it? No. Okay, but do I know my n? Yes, your 3 in there. That n in there and that n is actually related. So that's going to be 3 minus 1 multiplied by your difference, which is 6. Okay, you just found your so 4 is equal to A1. Still we don't know A1. And 3 minus 1 is 2 times 6. Okay, so I'm going to give you more practices on these 3 times of example. It's very easy. There is nothing hard. Have fun.